Hello everyone, again I'm back with the concept of mergesort. This is also one of the concepts related to divide and conquer. Divide and conquer is a methodology where you are going to divide the entire problem into sub-problems. So even mergesort also follows the same. So here you can see the definition of mergesort. Mergesort is a sorting technique based on divide and conquer. So already I told you like what is divide and conquer. And it also has a time complexity of bigger and log n. It is one of the most respected algorithms. So you can see how this mergesort is. So the basic concept behind this mergesort is mergesort first divides the array into equal halves and then combines them in a sorted manner. So if you take this mergesort, initially all the elements in the list will be divided into different parts. First, assume for a while that we have taken an element of 6. First, it will be divided into 3, then it will be divided into 2, and later it will be divided into 1. So that is how this works out. So, in the beginning, this mergesort was given by John von Neumann. So everyone is familiar with this person. He is the one who has given the architecture also. So this also follows the concept of divide and conquer. So if you come to the concept of divide and conquer, divide. So this divide says that we are going to divide the unsorted list into 2 sublists of about half the size. So you are going to divide the entire list into 2 parts. So this is a sorted technique. A sorting technique. So it says that when you talk about sorting, it is nothing but arranging elements in a order. So you are going to sort the unsorted list. So in this conquer method, you are going to sort each of the sublists recursively and you are going to combine them. So when you keep on combining them, so as you are saying that conquer is the one where you are going to sort the elements, and finally comes the stage of combine. In this one, we try to match all the sorted sublists so as to create the final sorted list. So it says that initially you have unsorted list. At the end of this entire mergesort, you are going to get one sorted list. So this is the small algorithm where we are going to implement the concept of mergesort, and this is a recursive concept. So as the process is being repeated again and again, here we have represented that in the form of recursive algorithm. So this is how your entire algorithm goes. So here you are going to create an array. In this one you are going to create some variables like I, k and p, which are going to represent as the indices values that we are going to do. And the entire concept of sorting comes over here. So you are going to make the comparison between the inner elements as well as, and as soon as the inner element comparison is being done, you are going to put that one into another list. So this process keeps on going till you reach to a sorted list. So that algorithm could be easily understood if you are going to use the concept of this example. So you can see how this works out. See, here the entire unsorted list is divided into 2 parts. It's not necessary that it should be exactly half always. It is depending upon the elements that you take. So as soon as that is being divided, you can see. So in this one again, here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements are there. In the second, you again have 4 and 5. Again this 4 is being divided into 2 and 2 over here. And in this one again 2 and 3. So this process keeps on going. This process keeps on going till you reach the last. See here. As soon as you reach the last, you are going to have some elements which could be taken in a single format or as a combination over here. You can see at the last thing, in this one you are making up the internal comparison. When you make out the internal comparison, you are going to sort the elements like this. Again, see here what we have done. We have taken comparison between this list and this list. See, you are going to make the comparison. This is the smallest element that you are going to get, and this is the smallest element that you are going to get, and finally you are going to get this. And when you take the comparison between these two, you can see 35 and 58. You can see how this comparisons are taking place. So this is how you are going to get. So this is how you are going to take it. And you can see how we are trying to make the comparisons and put up. See, the number of combinations are also getting reduces. This now we have 1, 2, 3, 4 sets, and we are making it as 2. As soon as we get the 2, we are going to make it as 1. So this is how you are going to get the entire list. So you can see one more example over here, how you are going to implement the concept of mergesort. So this is how you are going to implement mergesort. So as we see this, mergesort is nothing but dividing the entire set into different parts till we reach to a single element. As soon as we reach over there, again we start the combining process, where you are going to make the internal comparison and then combine the things. That is how you are going to take it. So you can see how this mergesort works. This example shows how it is going to be done. So hope you guys have understood the concept of mergesort. Thank you.